Hello everyone and welcome back to Stationeers. Okay then, so in the last episode we laid down all this. Hopefully eventually this will turn into a water generator, but right now it is a bit of a mess of piping and inline tanks and all that. So I think next up I would like to take care of the heat exchange between the liquid and gas pipes. So I think I will just go for small heat exchangers. So heat exchanger, small, direct, there we go. And yeah, we are really starting to run low on resources. I suspect this episode will have a mining montage, I guess we will see, for now. We need to have a heat exchanger between liquid and gas. It will be, yeah, upside down, I suppose. In fact, we have the radiators all over there. We could put these right behind them. Something like this. Although that will make it hard to hook up the liquid and gas. Yeah, I think this will do. So I will put these guys here. Right? Yeah, sure. But obviously facing this way, so gas pipes goes there, liquid pipe goes there. Good. And if we have to, we can put down some extra. That's fine. Okay then, so gas pipes and liquid pipes. Oh, first wrench. So gas goes that way, and liquid goes, let me see, that way, and then up, and hook into that one eventually. There we go. Well, I think next up, let's hook up the radiators. So after these pipes, we don't need any insulation. Okay. I have no idea how many, up. I have no idea how many pipes we will need. Wait, did we use... Where did I put the uninsulated gas pipes? Oh, there you are. Let me just check. So we will need to start going down. I will create a singular network under the radiators, I think. Basically the same way I did for these. Although in this case they were running in between. I don't think we will need to include more than these 3 radiators for this. If we do, then I suppose we'll install more, but for now this will do, I think. Okay, so we will need a lot of piping. Let's start with 1 full stack. So pipe, and this one there. Obviously the coolant will be CO2, so we can use the CO2 tank to fill it up. Okay, that's 1 full stack, and yeah, tell you what, I was looking at my water levels and I will go for whatchamacallit, soybeans in here. So we do have, okay, we have a little bit over 1 stack of soybean seeds. I will try to maintain 6 for now. 5, yeah, let's plant 6 of them. So that's 1, 2, 3, 4, 5, and 6, and maintain 5 seeds for now in case of emergency. Other than that, they are thriving, but I suspect they might, yeah, growing moderately. That's fine. So if we want to, we can start making some French fries again in a bit. For now, let's go outside and install these pipes. Okay, not quite enough, but you know what? Let's just use this last piece of insulated piping to finish it up, and we can call the outside piping done. But first, we need to make sure that the jetpack can actually reach it, so there we go, boost up, and there. So, you hook up there, and now this place is ready to be filled up with CO2. There. Okay. And I suppose at this point we can pick up the scaffolding. If you really wanted to, we could paint these gray, but it's fine. So, you guys come with us now. Our work here is basically done. Yeah. We can go inside, and how do we want to deal with the transportation of CO2? We need to start on this level, obviously. So the CO2 will come out of this pipe. It will go up through that way, hook into the relevant pipes, obviously. Then, yeah, some volume pumps will shove enough gas in there, which means it is actually fortunate that we have overprinted on the volume pumps. So we need to fill up this one and this one. Which means, I suppose we can hook them together, fill them up together, and then sever the connection. That will do the trick. Yeah, let's just do it now. So, we will need a lot of insulated piping. So, these... Steel is also starting to run a bit low. We might need to go out and start mining, obviously. I keep saying it, but... yeah. So, hook this one and this one together. This one will be pure steam. That one will be pure water. Heat exchange between the two, so they get cooled down together. This is waste from the water filtration. That is the combustor output. Right. And then that is the mixture, that is the pure volatiles, that is the volatiles unfiltered output that got shoved out of the base, and this is the active vent for the input of the volatiles filtering, so there. Anyways, this is now... Okay, let's go for a full stack. Also, don't forget, we still need to have enough to build the actual atmospherics, so let's just pick up some extra piping. You guys, how many we need exactly? Let me see. 1, 2, 3, 4, 5. Okay, so 10 pipes, I believe. I believe we need 2 for each. No, wait, not this. Where's the pipe? This one, please. Let me just check. So, atmospherics. Yeah, 2 pipe kits. That's fine. So, technically speaking, we only need 10. We have 12. That's fine. You can go here. It's okay. So, let me quickly install these, and then we will do the rest. Done. Then I believe cable coils with screwdriver, right? Yes. There we go. Okay, now we need to bring in the CO2. Well, first, let's hook these together so we can fill them up together, and then we will sever the connections once they're both filled up. Yeah, the easiest is going to be through here. There, and I suppose we can use this as the input place. Yeah. No. make a turn here, volume pump, and then long lengths of pipe. Okay, so this pipe now has a lot of CO2, presumably. Let's take a check. And it is 7.6 megapascals of CO2. Well, tell you what, we don't really need to have the volume pump. I think 7 megapascals of CO2 will be plenty good enough. So I will just hook these together, sever the connection, and turn these back into separate networks. Right, first let's pick up the volume pump. There. Hook these together. There, so now the cooling system is primed. Right? Oh yeah. 6 megapascals. And the jetpack is low, not the best timing. Can I quickly jump on this? There we go. So, sever that one, and that one. This one will curve back there, and this one will go straight through. And let's take a look. Be extra sure. 6 megapascals of CO2 coolant, and 6.6 megapascals of CO2 coolant. That will be good for me. Okay. Now we can pick these back up and repurpose them somewhere else. Okay, so we are back to normal at this point. And you know, once the storage setup is complete, I really want to have each and every one of the different, for example, different piping in all different colors. That would be kind of ideal. Anyways, I think we can put these guys down. We don't need the volume pumps. And these can stay. The gratings, I think I will put it here instead. There. And we don't really need CO2 piping right now. Although, we could replace all these with gray piping, because technically speaking they are CO2 pipes. Yeah, you know what, let's do it. This is the more sophisticated base, so might as well do it nice. Okay, so now the CO2 pipes are gray, as they should be. I suppose this one will be blue. This one will be... I believe the general wisdom is to have mixed pipes as purple. This one will be... purple... Yeah, this one will be purple as well because this is mixed. This one will be orange because this is a fuel mixture. This one will be red because this is volatiles. This one will be purple, so on and so forth. But anyways, we need to go home because we are, well, suffering a little bit. But first, we did plant these soybeans. They are right now... Ooh, some of them are thriving. Only this one is suffering a little bit. Not bad. But anyways, we are nowhere near the point where we can start making French fries again, but hopefully soon. Anyways, we need to go home, pick up food, water, and most importantly, propellant as well. Yeah, I got a bit complacent with the French fries and I keep forgetting to go home and eat. Having the luxury of spending a lot more time away from the home base is, well, a bit of a luxury there. So propellant is not good. And don't forget to waste canister to be vented there. First food, then a bit of water, and then we will eat the other potato. In fact, at this point I suppose we can cook the next batch. Okay then, so we are satiated once again. And by the way, sorry, I didn't mean to move the window there. So this one is now 14 liters, not bad. So we did increase the water throughput a lot, and the base is still 22 degrees Celsius. The temperature of the water is 38, not the best, but it will do. So yeah, I think the intervention in the last episode, in the last couple of episodes, was worth it. We have increased the throughput of the water generator a lot. Anyways, speaking of water, I suppose we might as well take some water into the new base. So it is now 1 liter. Let's just take... yeah, this much. Basically every single drop we have in the base right now. That's fine, it will condense out and we will have some water still, but whatever. So this is now, what is the temperature? 40. That is still okay for the plants. Let's just take one last sip of water and we can go. Why is this one draining? Is this guy in shadow or something? Oh, it receives enough power. Oh, wait. I think midday it might be in shadow. Yeah, I think the black hole is above that one. I suppose we can orient it towards morning. That will increase the efficiency quite a bit. So, no, not that way. That way, please. Yeah, I think this will do. Yeah, this will be enough in efficiency for us to keep the batteries full. Obviously, it would be ideal to have this one tracking, but yeah, it's fine. By the way, we did install that radiator. It is 35. Slightly still above the ambient temperatures, but a lot better than it was before. Anyways, you can go inside, and now we have 13 liters of, 12.9 liters of water. Not bad. Okay then, I suppose we could harvest these and plant a lot more. Okay, I will harvest the seeds. Not bad. 30 extra seeds. I think we are doing alright. And by the way, the oxygen in the base is 6.72, so 1% more than it was before at the last check. Now, I don't remember how many moles do we need to have to be breathable. Is this breathable right now? Nope. Very much not breathable yet, but we are getting there. Okay, alright, we are only half the atmospheric pressures. I believe we need maybe 40% at 50 kilopascals. Something along those lines. Anyways, let me take a look at the next thing we need to do. So I suppose at this point we can hook this one up to power. Yeah, you know what? We should have a transformer downstairs, right? I think we have one extra laying around. APC transformer, lovely. And we just need to hook it up to the main power spine, and we have plenty of cabling as well. Very good. Is this cabling will be enough? I think the power stops. No, wait. There it is. I don't think I want to hook the water generator to this transformer. So yeah, I think we will have this transformer here. Let me just quickly bring the elevator up or down, and you go down one level. Why can't I install this guy? It should be installable because we have the wall there now. So, oh, there we go. Okay, this way please, reversed. There. But we do have the cabling. Yeah, I believe the cabling comes down straight away. So we do have cabling on this corner. So we need to be extra sure that we don't hook these together. So first things first. This one will hook into cable cutter. This. There. So now this one should be hooked up to the network. Go all the way up to the usual 5 kilowatts and then one small step down. Okay. I don't really want to tear up these walls, just to check. I do believe this one goes straight out, comes down, and we have heavy cabling here. Oh, right, we can check actually. Yeah, we cannot place the cabling here, so that means we have cabling here. Which means we can come down. Okay, fine, we need to tear this place up a little bit. That's fine. I believe you just need to pick these up, that's all. And we need the angle grinder. Right, so all we need to do is make a turn here and come down here instead, so we can continue with the small cabling this way. There we go. Okay, so that will do for now. You can go back. Let's see. Flat wall goes that way. No, wait. No. The flat wall is a corner. You come back out. The flat wall is a corner, which means it will be... yeah, the round one. That way. But why can't I put you now? Flat corner round, what are you talking about? Huh? Wall, flat, corner, round. Interesting. We can definitely have this one here, and it was rotated this way, I believe. Right, so why can't I put the corner back? Okay, for some reason they're blocking each other. That's fine. We only need to replace a couple of them. and we are back to normal. Okay, so now we should be able to route the cabling the way we want. So we have the transformer here. It will come out and it will go towards the water generator. Let's get started. Alright, this one will be a bit interesting, but we can manage, it's fine. Okay, I do believe everything is now hooked up. Let's just double check. So we should be able to see everything from down here. Let's see, so that one, oh right, active vent. So that's fine. The two volume pumps are hooked up. Data and power, data and power, data and power. This one doesn't require power, that's fine. Data and power for that one, data and power for that one. Okay, so these cables are now one singular network and everything is hooked up. Good. What about you? How are we going to, I suppose, make a turn and go through this way? Yeah, I think that's going to be the easiest. And there we go. I think this is now okay. Let's take a look. So if all goes well, we should be able to power everything up now. So this one is feeding through. There we go. Good. 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 Yes. And yes. Okay. And so we should be able to read everything on the network at this point. Let's double check. So this one needs to go into network analyzer mode. Hydration critical. So we have one active vent, one filtration, combustor, volume pump, two air conditioners, another filtration, another volume pump, and the transformer reversed. Yeah, I think that is all the devices that we need. Good. Right. Now, I don't really want to filter off the excess stuff from the combustion chamber. It is just pollutants which we can harvest from the outside. Wait. We need to go back to the old base anyways, so let me just take a look at the water generator. It does generate pollutants and CO2. I am relatively certain it will not generate nitrogen, but never hurts to check. There we go, Atmo Analyzer. I am fairly certain that we will not see any nitrogen in the exhaust, but always make sure. And yeah, volatiles, oxygen, CO2, pollutants, and water. That's it. Okay, that's fine. So we don't really need to filter out anything from the exhaust. We can harvest CO2, volatiles, everything else is fine. I suppose we could harvest off the excess oxygen. That might not be a bad idea. I mean, we might want to also, before I drink, the combustor is still on, which means we should have less than 20 liters. Alright, I did just put a lot of water into this one. That's fine, we have enough for drinking at least. There, and the base is 20 degrees Celsius, and we are still inputting very hot water, so we have increased the throughput of the cooling, and we still only have 84 kilopascals. So we are still not siphoning the oxygen. That's not good. I mean, I suppose we can increase the temperature tolerance of the venting in. It is now 70 degrees Celsius. Yeah, tell you what, let's set it to 80. So I believe it is going through this one. You import, go back, edit, and let me see, waste temperature, waste temperature. Yeah, regulator. Okay, so this is where we are regulating the base atmosphere. So the waste pressure needs to be at least 1000 kilopascals, so we can actually have some heating capacity, or sorry, cooling capacity. But instead of 313, that is 40C. Yeah, 40C. Let's increase it to 80. So 40 more. Or do we want to go for 90 just in case? Yeah, you know what? Let's go for 90. Sorry, 363, so 90 degrees Celsius. So export the code, you can go back, and nice, too hot. But hopefully we will start seeing some CO2 making it into the base now, which means we can start siphoning of the excess oxygen, which is quite necessary to make sure that these guys don't die. Okay, the rocket is at 50%. Maybe in the next episode I will cool it down and recharge. Which means... I am tempted to shut off the water generator for a little bit. So we can prepare for a recharge of the rocket. By the way, how is the mapping going? Ooh, nice. Do we have any narrow lanes left? No, I think... Where is the... there's the mapping. Yeah, I think now we are creating 3 times as wide channels now. I don't know, maybe we are about 1/3 or maybe even halfway through. I don't know. 1/3 sounds about right. Do we want to cool it down now? The less we have to charge, the less strain it will have on the batteries. Yeah, let's cool it down now. So map, go back down to the landing pad, so set destination, launch mount, that's correct. Vulcan orbit current target is launch mount, that sounds good to me. Right, engine, can you please turn on? And now we just need to wait until it lands and we can get back to it. At this point it's all automated, so I think we can get back to it. And yeah, I don't know if it will come through the YouTube compression, but it is already barely visible right here, if you can see. If I move the camera, it will flicker a little bit. So anyways, I will come back to it once it lands, extend the umbilical and start recharging, maybe even refueling a little bit. Anyways, do we want anything from here? Take another drink so we can stockpile some water, vent the waste canister, pick up some oxygen, and we can go back. Yeah, at this point landing is automated, so... Oh, wait, never mind. We are getting a bit stinky, so let's get back inside and take a shower. There we go. By the way, how are we on charcoal? It is 9. We might want to make another batch fairly soon. Anyways, I can hear the rocket. There you are. And it's landing quite nicely. Okay, I will shut off most of the base right now. But first, obviously, put on the clothes. The radiator should be empty. It is empty. Okay. Water, turn off. Don't waste energy right now. You are fine. Yeah. And landing successful. Good. Yeah, let's just go outside and take care of it. Done. And let's just check. If I put some gas in here, it is 9 megapascals. I mean, it's not too bad. This one is set to 100 liters. Yeah, let's just fill it up to 13 or something. Just keep filling. I suppose as soon as this one starts climbing, it will be enough. But you know what, 20 megapascals will be fine. Okay, so the gas umbilical can be retracted. And it is back. And just siphon out whatever is in this pipe. And there. Done. Good. I suppose we can start mixing again, but... we have 2 megapascals and we have plenty of storage. What about the oxygen? 2.05 megapascals. No, don't put anything into the fuel mixer right now. I want to make sure that we have the oxygen siphoning sorted out before I start mixing some extra fuel. This will be enough for the next launch, that's fine. And this is charging. Obviously, let me just check. I do believe the bottleneck for the battery charging is the umbilical. It has been mentioned in the comments, but if I turn these guys off... Never mind. If we charge these guys one by one, or maybe 2 each... No, if we charge them one by one... Oh, never mind. This one is full, that's why. This one is full now. No, wait. Ratio, it is charging. Yeah. Let me check. Okay, never mind. Yeah. The bottleneck for the charging of the rocket is the umbilical, not the batteries. So yeah, all of these can be on. Doesn't matter. That's fine. It is peak midday. I think it will be fine. If not, I don't think we have anything in the base that is going to suffer if we have some power outages, so it's fine. And the tracking is on a separate network. It has its own power, so it's fine. Yeah, I think we can leave this alone now. So, water, one last sip and we can go. Okay, I suppose at this point we can start cooling down this cooling pipe. So if we turn this one on, set it to... let me check. Before we do anything else. I cannot read it through the grating. What is the pressure? 6 by 6, 6.6, right? Excuse me? Oh... I am dumb. This one is fine, but this one... I deleted this one, I believe. Yeah. When I sever connection between these two pipes and replaced them with gray ones, I deleted the gases. Well, that was a bit dumb, but not the end of the world. It's fine. I suppose 3 megapascals should still be just fine. There. Now they have equalized. There we go. Okay, now we can start cooling. So let's say 3 megapascals. Right now it was so high volume because it was outside midday, so that is why it was so high pressure. But let me just check. Carbon dioxide. So this one will condense out. Logarithmic scale maybe? No, that's fine. Okay, I don't think if we go below -5 degrees Celsius, we will not be in danger of any kind of condensation. Yeah, -9 is the absolute hottest where the condensation can occur for CO2. So I think it will be fine. If we set it to, let's just set it to 0 to be extra sure. So there, and we can start cooling the coolant. There, and I suppose we can start automating this. So if the outside temperature is hotter than the coolant, then go to idle. If we have any kind of cooling potential, get back out of idling. But oh wait, this one will require right, also solder is running low. I do believe we will need electrum. Let me just check. What do we need for IC10? Electrum, solder, steel, right? And copper, right? Gold. Okay, so this one, gold. Yeah, everything is running low. It is too late to go out for a mining expedition now, but next time, very, very likely. Anyways, this one is good to go now. Yeah, let's just print out a couple of these. We can print out 2 of them. After that, we are completely out of electrum. Right, I will leave this on printing, but first give me at least one. And I will sort out the code for that one. As I've said, each and every one of these will have their own individual chips, because if we need to adjust some values, I don't want to hunt for that one particular chip that will control that particular atmospherics. I want each of them to be done individually, so we can change their own individual values in one central place. So there. There, chip goes, sorry, there, chip goes in, open, and import should be empty. Yes, it is. Edit and pause. Yeah, sure. So we will need to have the filtration. So alias db, because this is the base device, and we need the filtration. And suppose I will name the registers as we go along. So start, yield, and load the into R0 from the filtration, the temperature input, and the waste as well. This one will be R1 and temperature output 2. So basically temperature input and output 1 are basically the same network, and output 2 is the waste pipe. So basically we want to set less than. Sure, set less than. So let me see, we will have a alias. The coolant will be the R1, obviously. If the internal temperature is less than, no wait, if the coolant temperature is less than the internal temperature, then we can start. If the outside temperature is below 100 and let's say 50, we can start cooling, it's fine. So we don't really need to have the internal, just the coolant. So R0, we don't need this one. Set less than, so if the coolant temperature is, also this will be the on-off register by the way. So yeah, 150 degrees Celsius, which means it will be 273, that will be 423 I believe, sounds about right. That will control the on-off, and we can set the filtrations mode to be the on-off register, and then we can jump to the start. So load the coolant temperature. If it is below 423 degree Kelvin, 150 degrees Celsius, that will change the on-off register, which will operate the mode on the filtration. So confirm, export the code, and it should be cold enough right now. Although it is radiating a lot, maybe it's a bit hot still. Let's take a look. Okay, it went to idle, which means that the... Okay, fine, I will check it through the window. It is very much too hot. But as soon as it drops below 150, it should turn on. Or go out of idle into active. I will try to remember to check back on it. As for this one, we should have the other chip at this point. On this one, how do we want to go about this? First, chip goes in. It is going to be very, very similar. I think on this one we want to check the temperature of the steam or the water, because it is also hooked up to the water. So I suppose if it is above, no sorry, yeah, if it is above, let's say 30 degrees Celsius, then turn on. So it should be basically almost exactly the same. All we need to do is change a couple of small things. So not the temp coolant, but this time it will be the temp water. Right? There. We need to check the input temperature or the output one, doesn't matter, the same network. And if it is above, 30. So basically 303 degrees Kelvin. And if it is greater than, so if it is above, turn on. I think that's it. Okay, confirm. Export the code. You can go in and it will be idle because technically speaking this is empty. So it is idling. Yeah. Okay, I will set it to 25. So it will try to cool it down below 30, but as soon as it drops below 30, it will switch to idle mode. And it is now active, which means that it is not cold outside. Good. And that means that the coolant pipe, this one, is cooling quite nicely, in fact. Not bad. Okay. So we have the water cooling sorted out, at least theoretically. Now we just need to sort out this one. Right. First things first. We will need some filters. So medium filter for volatiles, iron silver constant, and we should still have these, so we don't need to go out for a mining trip. Not just yet, at least. Yeah, 2 of these, and then 2 water filters. And also, I will try to remember to include a filter warning for these 2. So, you know, if the filters start running low, I will have an alarm light which will tell us that, hey, it's time to switch them out. So that's one. After that, exactly medium filter water, please. Thank you. There, you can go into the filtration right now. Done and done. And that's one and one more. And done. Okay, so we have enough filtering for a very long time. This filter lasted... Basically, I don't think we are below 90% on the original setup. On one of the filters, the other one should be 100%. I think these are fine. Now, by the way, did you... not yet. Do we want to have a threshold for the output pipe? So if it is below a certain temperature, it will also shut off. Yeah, let's just include that one as well. So we don't run it if it is already at temperature. So there, import, edit, pause. After all, yes, we do want to read the temperature of the input. So input, or yeah, input, that's fine. R1. So we will need to load into temp input from the filtration, this one, but this one. So that's fine. We need to check this one as well. So set greater than, and now it's not going to be on off. We will have the end check as well. So end, this one will be the temp coolant, this one will be the on off, and here the temp input will be set to 1 if the coolant is above, what would be 278. Yeah, so if temp input and temp coolant are both set to 1, then have the on off. So at this point it should be off, I believe, or set to idle. Yeah, because at this point the coolant will definitely be below 5 degrees Celsius. Oh yeah, it is 1 degree Celsius, so that's fine. Yeah, so now it will only operate if it has to. This one is fine. You can dump as much heat as you want into this one. Although, wait, can I read the efficiency? Can I read the overall efficiency? I wish the... this was a bit wider so I can actually read it. So we have input, temperature, pressure efficiency. Can I have processed input? I mean, we don't really need to... What is the... I believe for CO2 we can check the maximum amount of delta of temperature that we can achieve. So carbon dioxide. No, not hydrocarbon. Carbon dioxide. So I do believe we need to divide the specific heat with the latent heat or something. I do believe so. Is it really 47 degrees? That sounds a little bit too low. Let me check on the pollutants. Pollutants, it is 24.8. Oh, it's kilojoules. I think we need to divide this one with this one. So this is 2000 joules. This is joules. Yeah, I think so. You see, carbon dioxide. Yeah, 600 kilojoules. That sounds a bit more reasonable. Now it's 21.27. Is CO2 really only capable of 21 temperatures? Ah. No, I think it will be a lot better than that. Well, anyways, I think we can set this to... You know what? No, it's fine. It will run continuously if it can cool anything. It's fine. I suppose at some point I might check if we can... I think temperature efficiency might drop below, I don't know, 50%, and we can set it to idle or something, but I guess we'll see. For now, I think we can say goodbye because we are way over time and yeah, we didn't really have any time lapses in this one. So for now, all that is left to say is that thank you for watching. If you liked the video, you can leave a like, leave a comment, and maybe subscribe to the channel if you want. If you would like to support me a little bit more, you can do so by clicking the join button and becoming a channel member, which will give you an early and ad-free access to these videos. Once again, thank you for watching and thank you very much for your support. I will see you in the next one. Thank you and goodbye.